Alright class, we're going to start our lesson for today. And what our lesson today is going to be on, it's going to be over section 3.3 in our book. And that's on parallel lines and transversals. And as we're doing this, I just kind of suggest to you guys that you guys would take notes while we're going through it. So have your notebooks out, and at any time during the presentation you are more than welcome to pause it as well, as you can kind of just get caught up on what we're talking about here. But this will just be kind of a way that you can kind of learn our material for today. So, kind of starting off here, there are four theorems that we're going to be dealing with that involve parallel lines and that transversal that goes through them. And last week we talked about the different types of angles that form from a transversal when it intersects with two lines. And in this case right here, the theorems only apply if lines R and S in this diagram are parallel to one another. So once again, this only works if those two lines are parallel to each other. And the first of those theorems is called the corresponding angles theorem. And what that says is that if lines R and S are parallel to each other, then that means every single pair of corresponding angles will be congruent to each other. So just kind of review, a pair of corresponding angles would be like angle 1 and angle 5, for example. They're both located in corresponding spots to top left corner of their little groups of 4. And that means, since if lines R and S are parallel, they will be congruent to each other. The second theorem is the alternate interior angles theorem. And what that one says is, once again, if line R and line S are parallel to each other, then all the pairs of alternate interior angles will also be congruent. Alternate interior angles would be like angle 4 and angle 6, or angle 3 and angle 5. So once again, those angles would be congruent to each other. If you kind of look at the diagram closely, you can see that those angles probably do look like they're about equal to one another. All right, third theorem involves the alternate exterior angles theorem. And once again, if lines R and S are parallel to each other, then all the pairs of alternate exterior angles will also be congruent. The alternate exterior angles are like angle 1 and angle 7 in that diagram, or angle 2 and angle 8. So once again, you have more pairs of congruent angles there. All right, the final theorem, and this one is just a tad bit different, is that the consecutive interior angles, like angle 4 and angle 5, or angle 3 and angle 6, if lines R and S are parallel to one another, that means those pairs of angles are supplementary, or that they would add up to 180 degrees. So these are the four rules that we're going to be using, and we're going to use these four theorems as we kind of walk through the different examples that we have here. So we're going to start some examples now. If you need to get caught up and write these down, please pause the video. All right, first example we're going to go through is in this diagram that we just used. We're going to let the measure of angle 5 be 52 degrees. So in that diagram, that's what the measure of that angle is. And our goal is to figure out what the measure of angle 1 is, the measure of angle 3 is, and the measure of angle 8 is. And whenever we figure out the measurements, we're going to have to provide a reason. So first off, just the given part there, angle 5 there is 52 degrees. So that's what we have there. Now, angle 1, what you need to do is you need to think about the relationship between angle 5, the known angle, and angle 1, its other angle there. And since lines R and line S are parallel to each other, that means these theorems on this previous slide that we already looked at here, those theorems are all going to apply. So, angle 5 and angle 1 we kind of decided are corresponding angles. And the rule with corresponding angles, if you kind of look back at the theorem, is that if the lines are parallel, then all pairs of corresponding angles are congruent. So if angle 5 is 52 degrees, that means angle 1 is also going to be 52 degrees. All right, and then providing a reason which you would kind of provide is that you would use the corresponding angles theorem. And what you need to use then is just kind of identify which angles are corresponding. For example, in this case, angle 1 and angle 5. Right, if you provide that for now, that's all you really need here. So we'll kind of mark that in the diagram just to help us out as well. All right, next we need to figure out the measure of angle 3. And there's actually two ways to do this one. One of them is we can look at it from the original angle, angle 5. And if you look at angle 3 and angle 5, they are alternate interior angles. So we're going to use the alternate interior angles theorem. And once again, that involves angle 3 and angle 5. They are our alternate interior angles. And if we look back, the theorem says that all pairs of alternate interior angles are congruent. So that means this angle 3 would also have to be 52 degrees. All right. Another way that you could do it is, since we already figured out angle 1 was 52 degrees, the relationship between angle 1 and angle 3 is that they are vertical angles. So if you wanted to provide a reason, if you thought of it this way, that angle 1 and angle 3 are vertical angles, and we already know that vertical angles are congruent from what we studied earlier in the year, that's another way that you could cite that reason. So, I mean, you can pull back things from previous stuff as well as kind of your reasons there. So either one is acceptable. All right, then angle 8. So the next one we kind of figure out what angle 8 is. And if you look at that diagram, angle 8 is not a pair of any of those previous angles. So angle 8, its corresponding angle is angle 4, which we don't know. It's not on the interior, so it won't have alternate interior or consecutive interior angle. Its alternate exterior angle is angle 2. So we're going to have to do a little bit something different to figure out this one. And what you can do is, since you know angle 5 in that diagram, angle 5 and angle 8 actually form a linear pair. And by definition, a linear pair are two adjacent angles who form a straight line. And we also know that a linear pair has a sum of 180 degrees. So to figure out the measure of angle 8, the measure of angle 8 plus the measure of angle 5 would equal 180 degrees from what we studied before. You use substitution property, measure of angle 5 is 52 degrees. And finally, if you subtract over the 52 degrees, that means the measure of angle 8 would have to be 128 degrees. So just kind of writing that out, those algebraic steps there, you can kind of get that. Now, just one other thing to kind of talk about there. We can also figure out angle 2, angle 4, angle 6, and angle 7. I mean, you could figure out all those different angles. For example, starting with angle 6, it's vertical from this 128 degrees of angle A. So that would also be 128 degrees there. Angle 5 and angle 7 are also vertical, so that one would also be 52 degrees. And then this pattern kind of continuing. Angle 8's alternate exterior angle is angle 2. That theorem says that they would be congruent. Then the angle 2 and angle 4 are vertical, so they'd also be congruent. So you could figure out all those angle measurements, and it's got to be one of two things. Whenever we do these problems, if the two lines are parallel, it has to be one of two things you kind of work through there, as you can see that pattern. All right, our next example is actually going to involve some algebra. And once again, we're going to use those four theorems to help us set up an equation and solve for x. And once again, in directions, it says that the two lines are parallel. So that's very important, because the only way we can do these problems is if they are parallel. It's the only way these relationships hold true. So in letter A there, first thing we're going to have to do is we're going to have to identify the pair of angles. And if you kind of look at them, they're both in the top right-hand corner. So that means those angles would actually be corresponding angles. Once again, flipping back to our rules, corresponding angles theorem says if you have a pair of corresponding angles, the lines are parallel, that the angles must be congruent. So right here, that means that 2x minus 45 degree angle would have to equal the x plus 30 degree angle. All right, then just the steps for solving, we'll subtract the x over to get all of our x coordinates or x variables on one side of the equation. Then move that 45 over by adding it over. Oops, adding the 45 over. And that means that x would be equal to 75 in this case. So that would be our solution as we're solving it there. All right, second equation then, or second drawing, involves another pair of angles. Once again, the lines are parallel like we said before. And in this case right here, we have a pair of consecutive interior angles. They're inside the two lines on the same side of the transversal. Rule with that is that they must be supplementary, which means they would add up to 180 degrees. So how we would do that? 13x plus 23x equals 180 degrees. In this particular problem, we'd add like terms together first. 13x equals 180. Divide each side by 36 to solve for x, which means x would happen to be 5 in this case. So once again, just kind of by using these properties, you can set up an equation and solve it. All right, last example, and this one might be a little bit more difficult for you to kind of visualize. It's not that hard of a problem, but it's just got a little bit more going on here. And once again, find x if the two lines are parallel. So in this case right here, I'm going to put these two little arrows on these lines. All that means is, if you ever see this on lines, it just means that they're parallel to one another. So just to kind of identify which lines are parallel there. Now, what we have here is we do have two lines going through them, and these are actually transversals that we do have. It's hard to imagine it, And maybe to help you see it better, imagine this one on the left, and if I just extend it, I know that's not perfectly straight, but you extend that transversal, maybe you can see those 4 different pairs of angles there. So we're going to completely ignore that part on the right there, that triangle part on the right, and just looking at the left here, we have this 70-degree angle. Now, as we extended that transversal, you should kind of know that alternate interior angles are always congruent by the alternate interior angles theorem. So if this angle down here is 70 degrees, its alternate interior angle, so inside the 2 parallel lines, alternate side of the transversal, this would also have to be 70 degrees. So what that should do is you should kind of notice then that the 70-degree angle, that x degree angle, and the x minus 20-degree angle, all 3 of those together form a straight line. So what we could do is we could write out an equation of 70 degrees plus x degrees plus x minus 20 degrees would equal 180 degrees. So we have our algebraic equation in that sense then. So if it helped you to extend that line, by all means do that whenever you want to. But just so you know, the transversal, it can stop on those parallel lines, but you can imaginarily extend it. All right, steps for solving this. Of course, you add like terms first, which would give you 2x plus 50 equals 180 degrees. Next step then, it would be to subtract the 50 over. It gives you 2x is equal to 130 degrees. Last step, divide your 2 over, which will give us an x value of 65. So those are kind of your different examples that will go along with these theorems that we work with. All right, so basically that means our assignment that you can work on the rest of the class period, now that you got this in video done and you enjoyed, is page 146, 8 through 26, and then 28 and 30. So those will be kind of your different problems you can do. Now, the last couple problems on there are actually proofs, maybe not the last couple, but in there you do have proofs. And remember, what you just learned is you learned 4 different theorems, and these theorems could be used as reasons and proofs. So if you're trying to prove that, for example, angle 3 and angle 5 are congruent, and you're given that angle or line R is parallel to line S, what that means is you can say angle 3 would be congruent to angle 5 because of the alternate interior angles theorem. So just so you kind of know, if you have questions, I'll be back and we can go through it tomorrow, but you can use these theorems as reasons in your proofs. The other thing, just as a reminder, is to do this for tomorrow, download GeoGebra on you guys' computers. So make sure you go to the GeoGebra website and download it, just kind of where I showed you to do that last week. Please do so because our lab is going to be tomorrow that we use GeoGebra. So make sure you come prepared for that. And if you need to download it at home, do so. And once again, if you have issues with that, please come in tomorrow morning and I can help you out. All right, any questions? Your sub, I'm sure, will be more than happy to help you out. And I hope this helps you guys kind of learn the lesson for the day.